Okay, so a little bit of context before the video starts. I met this graffiti artist named Mark and asked him if he wants to do LED artwork with me because I thought it was a really cool idea and I think both of them will work nicely. And he said he'll do it, but first he wants to see a prototype of it so he can get some inspiration, see what design he can come up with. So therefore this was the prototype that I showed him. And now recently he told me that we'll do it together, so I did A4 size mats, gave him, and he just needs to graffiti paint them, and then I'll put the LEDs where he wants to put them. So if I do that project as well, I'll show it to you as well on YouTube, because I think it'll be really cool as well. See like the upgrade, you know, from the first one to the second one, and how much better it is. Also for the video quality, since I just used my phone to record the video. So yeah, if it's like shaky or doesn't look natural or anything, uh, again, it's just my phone.
And yeah, I'm thinking about like starting doing personal projects and just upload them on YouTube as well. And the idea of this first one that I did was to create an LED artwork with a bird and make it like move like the lights of Las Vegas from one side to the other, while this one here stays solid. And I did that by just placing LEDs on one of these mats that I like laser cut made with like just many holes. And on the other side, the wires are really soldered. They are just like twisted around them. It should be good enough of a connection for just LEDs, while like the heavy circuitry is done on a normal copper breadboard, like this one here. Okay, so let's start with like the beginning. Sometimes I just like to like plan out my ideas and just make them as basic as I possibly can and then work on like the separate parts to each other. So for this source, we go straight to the 555 timer, and the timer will interact with the counter, making it counting up, like 00011011, and the counter will be connected directly to the decoder, and then the outputs of the decoder will be on the LED displays, basically just the LEDs themselves. Okay, let's start with like the 555 timer, which is here. This is the diagram that I drew for it, like the pins and the names of the pins. And as you can see, you connect a power supply bypass capacitor here from the ground to the power source, and from the power supply you connect other two resistors, R1 and R2. Why R2 is a potentiometer is because I like to use a potentiometer instead of a capacitor to control the timing. Because I use a potentiometer, it's a lot easier to just change the value of the resistance and therefore change the speed of the timer of the 555 timer instead of changing like the capacitor, solder it and then unsolder it, change out the capacitor. It's just a lot more convenient for like me and the other user if they want to have a different speed on the timer. Okay, and the rest is pretty easy. The reset and the power supply are connected directly to the source because they always have to be on, and the ground with the control voltage are connected to the ground and through another control voltage smoothing capacitor. So like the frequency would be a lot better with this capacitor here. It doesn't have to be a lot, either like 10 nanofarads or 100 nanofarads is enough. Now the threshold and the trigger, I put here like some information about it. Basically the trigger is at the pin of the flip-flop when the voltage drops below a third, which is the VCC, which is here. Okay, and this causes the switch from a low to a high. So basically, when the voltage drops below a third of the VCC, then the output will become a high from a low. And the threshold does exactly the same thing but the opposite. Basically, when the VCC is higher than 2/3, it causes it to go from a high to a low, which is here on the output from a high to a low, and they're connected to each other, so they like complement each other and like change the state from like 0 1 0 1. And basically because of these two, that's why like the change is possible to go from a 0 to 1 and 1 from a 0. Okay, so now we move to the counter right here, and this is a diagram for the counter that I'm using. Basically is the voltage supply that goes to VC straight, goes to A as well, because you know you need at least one input for it to function, and the rest of the inputs such as B, C, and D are connected to the ground because we don't need them. The clear is connected to the ground as well because we won't need the clear. We don't need to clear anything. The load is connected to the VCC, and the QA and QB are the outputs. We will use only two of them because I'll need only four combinations. You know, the 0 0 0 1 1 0 1 1. And the input is the 555 timer output that goes straight to the up. Why does it go to the up and not down? Well, when 555 it's a 1, it will count up by 1. And it's just, I think it's just convenient, it's more logical to connect to the up, and therefore you take the connection of the down and just connect it straight to the voltage supply. So each time the timer hits a high, the counter goes up by 1. And here I put like the symbols. Q, A, and B are the outputs. Up is when 555 it's up high. Down has to always be high. A needs to be set up to a 1, to a high, and load has to be always high. Now, and this is the truth table, you know. It's really simple since there are only 2 outputs from the counter, even though it can be up to 4, we need only 2 of them. Now the decoder. This is a simple diagram of the decoder. Basically, you get 2 digital signals in here, and you get out 4 analog signals. And this is the logic gates of the decoder if you want to build it with logic gates and not use one of the IC chips. Basically, you get the 2 inputs, QA, QA, you get 2 NOT gates, and you get 4 AND gates. And it works as a decoder because from this formation, one AND gate will always be a high. So when this one will be a high, it will be when QA and QB are zeros. And because this one is high and those two are different combinations like 0 1 1 0 and 1 1 1, then those 3 will be low because they don't match for the AND gate like this one matches. I mean, like you can see that on the truth table as well. You get the singles QB and QB, and when both of them are 0, both of them go through the NOT gate, which results in the LED 1 to be active, while the other 3, 2, 3, and 4 to be inactive, and so on. And then when it's 0 1, the LED 1 is inactive because it doesn't meet the criteria for the AND gate. However, LED 2 will be on, and then 3 and 4 off, and so on. And this way, I won't have the problem because, as I said, I want to be like the lights of Las Vegas. I don't want 2 lights to be open at the same time. I want to be one open and then switch off, and the next one to be open while the other 3 are off. And that gives it the illusion that it goes one by one moving. Without a decoder, then it will go one by one, and then sometimes you'll have 2 of them while this one will be off all the time, and then this one will be on, and then those 2 will be off. It won't make any sense. It won't fit what my aim to do for the project. So the decoder was an important part of it, and it's a pretty simple circuit, to be honest. It doesn't need that many components, and I'm kind of proud of it. I think you can do it better. I think you can use something else to like make it more efficient or easier, but to be honest, like this method I think is the cheapest one, since like the chips are really cheap and you won't need to use an Arduino or anything like that to like, okay. Okay, so this is the last part of like my project presentation, which will be the end result of it. So there's a timer, there's a counter, there is a decoders like the NOT gates and the AND gates, and here are the outputs. Now you may realize something strange here. It's also connected to the, how is it called? Yeah, straight to the socket, so it's generating AC power. Anyway, you will notice that the red LED doesn't turn on. Well, that's it because it's not connected with any resistor, and the mistake I made was like to assume that all LEDs use the same current and voltage while they don't actually do. For example, the red LED actually needs more voltage and current, no, less voltage and current to properly work compared to the white ones. That's why it's always off, and that's why the white ones always work on. And here's the potentiometer that I told you about for the 5-hour timer. Had a bit of difficulties with it because like I put it on this side and I like reverse it, but it's fine, it works as seen here. And this one, it's like more of an example for me to see before I connect it to the main thing, which is this one here. As you can see that I managed to make the red LEDs work here while they don't work straight out of the decoder. That's it because I connected on the back. It's got a different okay, there we go, a different ground connection compared to the white LEDs. The white LEDs have a small resistance, while the red LEDs have a high resistance, and they are kind of two different grounds for them, which, as you can see, it satisfies them. It allows the red ones to be on while the white ones are on as well. And this one is a different ground and power source as well, because I want it to be a solid light compared to the other ones. And it does have the effect that I want. However, there's a problem. As you can see, like 3 LEDs are on, but the 4th one doesn't function. And that's really strange as well, since like we know it functions here with the prototype test. And I actually did this project around the end of December. However, I waited for a longer time to like see if it still works after long periods of times, and to see what possible faults are in there, so I don't make them again, because I want to like work for a long period of time. I don't want to like make it work for like a few weeks and then just like break. And the mistakes I noticed, like the first mistake I thought it was like, I thought one of the LEDs on this series was burned, and therefore, because all of them are connected, they will like not function, current won't go through them. However, that can't be the problem because they're connected in parallel anyway, so they should still function even though one of them is burned out. And if I allow me to like turn it on the back here, this is my problem right here. As you can see, it's just a mess because most of the outputs are connected here in this bundle, and because the wires are really thin and twisted around, it's very hard to fault find it. It's even harder to undo one of them without breaking the circuit. And the soldering was done like this as well, between the cables, between the cable for the LEDs and the main cable from the circuit board. And these welds aren't that well done, so they might as well just break one of them. But the problem is that I put some rubber on it, some duct tape on it as well, and yeah, I need to like undo it to see what's inside of it, if it's like a broken connection or not, which can like take time and cause other problems as well, I guess. Anyway, and the decoder like outputs are connected in the next way. You just I color coded the log pins of the LED and just connect a yellow one here, count 1, 2, 3, and the next 4th one connect another one, and so on. And that way, the decoder understands that when the first LED is on, then turn on all the yellow ones, and that's how it's got the effect as well. That's what I do it for like the blue ones, the orange ones, and the green ones. And I did the same for this one here as well for the red ones. Only the white ones are the different ones since they are connected straight to the power source, as you can see with the red wire. So yeah, I think it's pretty good for the first one. And just like I feel bad since it doesn't work the way I wanted to, since one of the blue ones isn't twisted correctly or isn't connected properly, and it just ruins the entire sequence. But this is like the first project. It wasn't that hard to like make. It was more of like trial and error because this is the end product, but it took me a while until I figured out how to do it. And hopefully there will be like more personal projects to show you. Oh yeah, I almost forgot to show you the potentiometer and why I put potentiometer instead of like a capacitor or a normal resistor. Let's see if it goes. Just a second. Let me like increase the speed, and as you can see the speed has been increased, and this is by just moving the potentiometer a little bit with the screwdriver. Yep. And I can also decrease the speed by moving the potentiometer on the other way. And because this is supposed to be artwork with LED, I think it really fits the thing, the idea of like being able to make it faster or slower based on the potentiometer value. Anyway, so this was my first project and my first video on the channel, really. And I'll start working on new ones, and I'll update you as well on those as well. So, I guess bye.